Thank you, Bhushan. Hi, I'm Brian Myers. I have an odd career arc that I might just briefly sketch for your amusement. I started in graduate school in liberal arts, but my hobby was writing books on programming. And so when it turned out it was going to be hard to get a job as an English professor, it turned out I could get a job as a technical writer for a compiler company. And I managed to parlay that into what I really wanted to do, which was being a programmer. So that's two lateral shifts already in my career, one from liberal arts to technical side, and one from writing to programming. I stayed as a developer for a couple of decades, moved up into management, was ejected from that, and made my way into information security, where I've been for about 9 years now. I was the HIPAA security officer for the local division of WebMD. I've been a application security architect, started the application security team at a Silicon Valley startup. And since then, I've been doing consulting, which I now do independently, largely helping smallish software companies set up and run efficient and compliant information security programs. That's my background. And pleased to meet you.
Now, Brian didn't mention that he worked for Borland and Escape. If you guys have heard of those companies or are aware of those companies. Let's move to Tim now. Tim Morgan. I've known him for a long time. I would like Tim, you to introduce yourself, please.
Sure. Thanks, Bhushan. Hi, I'm Tim Morgan. I guess as far as my career background, I got interested in security at a pretty young age. Much to the chagrin of my teachers. I studied computer science. I finally, when I was in grad school, I landed my sort of dream job, which was to become a penetration tester. So basically hacking for work, actually getting paid to hack into people's stuff. It just seemed like the coolest thing ever. So I did that for about 15 years. And then after that, I got this harebrained idea that I should start a software company. And so for the last 8 years or so, I've been building Deep Surface. We're a local software security company that does security posture management and vulnerability management. Anyway.
Now, I don't think Tim told you that, and I think I can share that he knew everybody's grade in high school because he was such a good hacker at that time.
Did you change any of the grades?
I pretty have straight A's.
Now we have Cory Perkins. Cory, please introduce yourself.
Yeah, thank you. I'm Cory Perkins, CTO for a local software company, Springbrook Software. I got into the software space back in 1999, doing phone tech support. I've done a number of different roles in companies and then kind of made that switch over to software development and did work as a software engineer for a number of years, building a number of the products that we have, kind of moved into management. And then throughout the years, made it up to the role that I'm at now. So now I'm overseeing our engineering. I do have a counterpart in security. He's actually in Arizona, so I couldn't bring him up here, for this. But him and I work very closely together on all of the initiatives, because one thing that I think is really present about security is it's not one person's job. It's not the CISO. It's not, your head of security. It's everybody's, and we all have to be thinking about it and contribute to be successful.
Thank you, Cory. Now let's dive into it. I would open the first question here, and my question is very simple. To build a secure software product, we face a lot of challenges. And I would like to ask the panel, what challenges are here now and what challenges they say in the near future. So let's start with Brian.
Yeah. Okay. Challenges. One of the biggest ones I often see exists everywhere, of course, is competing priorities. So when I'm working with the development team, just like anybody who has a set of, a little lens on what I need out of the security team, I want their time to focus on the things I care about. Other people want their time to focus on the things they care about, like delivering products and features. And so there's some built-in competition there that we always have to think our way through. I'd say another is inconsistent levels of security expertise across a company. Naturally, this is again a normal systemic thing, but it's a challenge we deal with. It comes up because typically the people on the development teams I've worked with weren't hired for security expertise and have varying degrees of interest in it, and sometimes assume that anything that has the word security on it should be done by the security team, which is often me, or me and two people for a team of 40 to 100 developers. So who's responsible for what and what they need to know to do it, and how best to spread that knowledge around is another problem challenge to think through, with a slightly different solution probably depending on which company you're in. Another common challenge is a backlog of unaddressed vulnerabilities. You buy a scanner, run it on the code you've got, suddenly discover 1,000, 2,000 open source libraries you're using that theoretically have some vulnerability in them. Some form of a backlog like that is a common challenge. Another one is what degree of change control you want, how carefully you want to regiment your release procedures, change and release procedures. And that has to be balanced against the need of the team to be agile and move quickly. So that's another challenge, is striking the right balance there. I'll list those as a few to start with, and I don't want to say everything. I'm sure our other panelists have other things to add.
Cool, thanks. Yeah, I mean, I think the first point that you brought up is really hit home for me. I mean, I was spending 15 years looking at other people's code, telling them how to fix it, telling them the things they should be doing to make it safe. And now I'm on the other side where I'm actually building a product, running a company, trying to figure out how to ship the next thing. And wait, this big list of security requirements, there's no way we're doing all that. It's impossible. And I think people understand that. I think even your customers who are asking you to follow some sort of compliance regime understand you're not going to do all of it, but it's really hard starting a software company and still having to take on that stuff. It's a big list of crap that really needs to be pruned down in a way that is manageable. And I think any team is going to deal with that to some degree, but it's particularly difficult when you're a startup, when you just have 3 or 4 people trying to do everything, right? So for us, that's been a big challenge, and just picking and choosing what security controls you actually put into place that will check some boxes for you while actually trying to make the app secure, which is a completely different thing, right? So anyway, that's been the biggest thing for me.
Yeah, and I would say, the only thing really to add, I mean, there are a lot of challenges out there, trying to build secure software, but anytime you're starting something new and even modifying something existing, is going into it with security being a primary requirement out of the gate. A lot of times, that's not how these projects start. It's, we want this thing, we want this functionality, we want to be able to do these things without really considering what makes it secure out of the gate. So I'd say one of the biggest challenges that a lot of people face is thinking about security at the beginning, not in the middle of the process or the end of the process, but doing it at the start of the process, because there are some fundamental changes that may need to happen to how that application is architected to make it securable, and make it, not vulnerable, which can cost a lot at the end.
Great. Go ahead.
If you don't mind, Bhushan, I'd be interested to know if people in the audience have other challenges besides the ones we've listed that maybe we should also think about.
I was going to ask the same thing.
One of the online speakers, Angelo, was asking, can any of the speakers talk about cyber survivability, an offense approach, not a defense approach? And he's referring to I don't know the name, what the CSIAC.org and NIST 800-53 checklist mentality for cyber risks. And I don't know if you guys know about that. Yeah. So he was just asking for if you guys could include that where you're talking about it.
Yeah. You have a question later, Bhushan.
We'll take that question
Okay.
We'll speak later on. Anyone else from the audience? Yes? Oh, of course, of course. I like it. Has to be interactive.
Yeah. So asking for a friend here. um, so for a small company, kind of get, I guess you'd say a startup, but it's a nonprofit that doesn't have a lot of security expertise. Are there like some frameworks or approaches that you might suggest for sort of incorporating security more into our kind of process? So I'd like to avoid the, as a tester, I'm going to go run, get some pen test tool, discover a boatload of issues and, kind of overwhelm stakeholders with noise.
Yeah, so we'll take a brief answer to that, but we have a question related to that. So we'll address that as we go on.
Well, I'm just going to quickly say that was the topic of my last talk at PNSQC a few years ago, starting a security program on a shoestring. And just briefly, it did involve using an open source tool that would do a kind of scan on your software, but not feeling like you had to address everything at once, picking top priority things and learning those and then fixing them and kind of working up from there. And I specifically started with the QA team, imagining a scenario where that could work its way from that starting point, that little camel's nose in the tent, to building out a larger program. I'd be happy to talk more about that. There is a paper on it on the PNSQC records. I don't know if that's going to be a direct answer to your question, but I couldn't resist that little plug.
All right, now we move to some nuts and bolts of security. Tim brought up security controls, and it's important to have them in place as soon as we know and as soon as we start software designing. So I want the panel to provide some thoughts on that. So let's start with Cory.
All right. So starting with, like a new project and you're trying to get the controls in place, the things to really think about are, one, during the design process, what are the things that people should have access to, shouldn't? Is there data you should protect? Who should have access to it? And then it's not just the application, right? You should be thinking about the infrastructure that's going on, those groups being involved early in the process. And then also thinking about how are you going to maintain after you deployed it? What controls are you going to put in place to make sure that your libraries that you're including are getting updated when vulnerabilities are detected? How are you going to know about those vulnerabilities? Do you have a control in place for that? There are a number of tools out there that can help you with a lot of these processes, but a lot of it is just thinking about how to structure the controls you actually need and then finding tools that can help you in that process. There's a lot of different ways to approach that, but I just want to kind of start off with that and then kind of pass over to Tim.
Sure, thanks. Yeah, from my perspective, I think it is extremely important to try to establish some norms on your team that just avoid a lot of security problems up front, and that ends up being way cheaper and much easier to keep security under control without necessarily making your developers feel like they're being held back or constrained in any way. And so some specific examples that I've used as I established the product that we're working on today, I was the only developer on it for a while. And I knew that as I hired people that I wanted to have a set of norms in place that would just avoided whole categories of problems. And so one of the things, just as a simple example, is I very early on, I built the front end for our app, or all the JavaScript and everything. I put into place a very, very strong content security policy in the application. And that's common. A lot of people use these, but I started off with something that's so restrictive that effectively cross-site scripting is not possible. It simply isn't possible because there's no way to bootstrap your code if you're an attacker. And so once I got that in place, then yeah, maybe we've had to make some relax that policy a little bit over time. But when I hired a front-end developer and he has since completely rewritten the front end, he's never complained about that policy. He's never complained that policy slowed him down, caused him any issues. Now, fortunately, we're in a position where it's an enterprise application. It's not something put up on the web with a whole bunch of public dependencies, JavaScript libraries being pulled from CDNs and stuff, right? It's not that kind of thing. But he's never complained. And it's like, wait, I never had to deal with cross-site scripting at all. And he's using development frameworks that prevent them to begin with, but then also this extra control just avoids the issue, right? So if you can start with the right kind of restrictions in place that don't necessarily get in the developer's way, then you can avoid a lot of issues. I guess the other area that I'd like to follow up on Cory's comment about dependencies, the third-party code you bring into your application probably accounts for 90% of your code, right? I mean, at the end of the day, if you look at the entire software stack, it's not so much we're building on the shoulders of giants as on the shoulders of a bunch of minions all the way down, right? Because there's a whole bunch of little packages. It's all this software that goes all the way down, and any one of those could have serious issues. So how do you decide what those are? Are you taking into account security at all when you're deciding what your dependencies are and what your stack is? A lot of teams don't at all. And so then you end up with way more of those minions than you really need. And now you have a bigger problem for maintenance, right? So if you can just early on kind of establish what your team is allowing into your stack, then you'll have a smaller problem later.
I like its minions all the way down. That's changed my metaphysics. Thank you. I was just going to add, we've had a good list of particular measures to think about putting in place. So taking a step back, what you always do in security is think, what are the risks and which risks do I worry about the most? And that will help you decide which of those controls and measures we've heard about you want to put in place first. So if your biggest worry is that you might adopt something that had a vulnerability in it, which should be high on your list, like, Log4j, and there are lots of times where the third-party vulnerabilities lately have become more and more prominent. That's one risk. Another risk would be a developer accidentally introducing a vulnerability. Another, in their own code. Another might be a developer maliciously introducing a backdoor. That's a control you want to think about. Accidentally pushing up to live a change that isn't ready is another risk you might think about. Another risk would be after an attack occurred, would you be able to determine forensically what had happened that made the attack possible? Those are some of the kinds of risks that might dictate the measures you choose to define your SDLC, your software development lifecycle.
Now the burning question, who is responsible to make sure that controls are identified and they are in place? Now, I bet audience will have its opinion too on that. Let's start with Tim.
Yeah, I think responsibility is actually one of the biggest drivers of risk in our world when it comes to software, when it comes to security. The reason is just because businesses are always trying to find a way to shift that responsibility, right? If you go back to the very beginning of computers, and I guess Bhushan mentioned earlier that when we were chatting earlier, that this conference has been around for 42 years. Okay, so if we go back to that time frame, which I don't go back that far. Okay, I was only 3, but I was starting to code, but I wasn't at that level yet. So if you go back to that time frame, I have to guess, or maybe a little bit earlier. I don't know. You tell me. People have been around that long. People bought computers that didn't have a whole lot of software on them at all. They bought mainframes. They bought big hulking beasts. And then they hired programmers to come in and do the work because software is easy. The hardware is the real thing, right? The software is the easy part, right? So then you would actually hire your own developers. And you're not a tech company. You're just a company that wants to automate some things. So you'd hire a developer to go do that thing, right? And then came along the 80s where it's like, or 90s, whatever, where, hey, there's all this shrink wrap software I could just buy that has a whole operating system and all the productivity suite on top of it. And so, I don't need to have programmers anymore. I can outsource the building of software to someone else. Okay, now this arc keeps going, right? Every step of the way, then everyone's running in their data center. Now, when people don't want to run their own data center, so we're constantly shifting the responsibility of the automation onto someone else because the businesses do not want to deal with maintenance. And security is maintenance. And it's a big driver of that push actually nowadays is I'm going to put it up in the cloud because I don't want to do a patching, right? I don't want to deal with any of that stuff, right? So if you look at it from that long-term kind of arc, then consider where's the responsibility for security and how well have we done over time at actually, making things safe? Well, we've done a really bad job because we outsourced operating systems to other people. And now, as an example, and I always pick on Microsoft because they're, you know, the leading example that everybody can understand. 50 to 100 CVEs a month being published by Microsoft in the code we use. Many of them are exploited in the wild before we have a patch available. You know, so we didn't solve the problem by outsourcing it, right? Like, and as soon as you shift that responsibility to someone else, then it's actually a bigger problem, right? Because they, you know, there's always incentives to cut corners, right? So as we outsource things to cloud, as we continue to outsource more and more of our stack, it'll just get worse, right? Unless we come up with a way to, hold those parties accountable. And I don't know what the solution is to that, but it will get worse. It's important. So anyway, I don't know which direction to go. Cory.
I'm not sure how I follow that up, but when talking about, who's responsible, I mean, if we're looking at, from the constant outsourcing, like that Tim's brought up, there's only so much that we can effectively do today, right? If we look a little closer, at our, ourselves and our own companies that we're working for, the products, that we're building, we're testing, and so on. Looking at responsibility, for the applications, it's the companies have choices on whether or not they want to outsource or not, but also who's looking at that responsibility internally and either, making those. If you've got a CISO, it kind of starts there in terms of being able to drive that, security program. But we're all part of the security program. We're all responsible for security and for getting those controls in place. If you see something that's a problem, it's not being addressed or it's not being taken, raise it to the right people. If you have a security council or committee, bring it up to them. If you've got a CISO, bring it to them. If you have none of those, bring it up through your chain, elevate, bring it to light. We've all worked in a variety of stages of companies. We talked about a very small nonprofit. I've worked at a very small software company. My first one, I was employee number 13. So very small company. Security was not even a concern at the time at all. Like it was never discussed. And, the company I work for now, we do make cloud software. We're thinking about security all the time. And it's becoming a bigger and bigger topic because, as Tim pointed out, the industry as a whole has not been very good, in terms of securing their software and thinking about it through all that time. So it's really important for us all to have a voice in making sure that that is changing. And you're going to start to see more support from the top down because everybody's being impacted. I mean, there's stories every week, every month of giant companies getting hit with big data breaches, big vulnerabilities. We had some years back with Experian, 150 50 million Americans, their data got, leaked. We had Target, and the list just goes on and on. And while we may not be, looking at those numbers, the majority of us, we're still having stuff that we need to protect and ensure. So it's really all of us really being responsible for making sure that we're trying to get those things in place.
Oh, I'll be quick. I'm just going to agree with Cory in slightly different words. But it's interesting, the question, who's responsible for the controls? At some level, there is an explicit answer to that in a well-written information security management system program. Explicitly, the CISO is responsible for ensuring that the organization has an appropriate set of security controls to address whatever risk the organization is worried about. However, in most organizations, most of the company does not report to the CISO or whoever has that role. It is always that title. The controls are things that are supposed to happen in HR, things that are supposed to happen at the call center if you have one, in the operations team, on the development teams. And the CISO cannot directly, or the CISO's team should not directly supervise all those teams. So clearly the CISO role is a guiding and advising role, and the responsibility is shared, which is what you were saying.
Let me hear from the audience. Any thoughts? Come on, guys, on that question or in general. Yeah, come on. You guys are all smart people here.
You mentioned earlier about the competing priorities. Is there a role for regulation in that in terms of applying a requirement or forcing a requirement on companies?
Yes, there is a role for regulation in adjusting the allocation of resources and how much attention gets paid to security. The government is clear. Our government is clearly trying to influence that with some success. The most obvious effort from the government is in federal contracts where they impose federal standards, and those require that you conform with or comply with certain security standards that require specific controls to address certain risks. So certainly regulation can shift that. I think that what's required for complete success, though, or as much success as just possible, is definitely more than regulation. It requires culture and a supportive staff and a company that consistently welcomes security concerns and prioritizes that. This isn't true just about security. I have a friend who was a director of accessibility for a software company, and his concerns were very much like mine. We kept having the same conversations from different points of view. It was a kind of accessibility we both viewed as a kind of quality that needed to be incorporated in the product that was not the primary functional priority of the teams, not generally designed or specified by the product manager, and always competing for the attention of the software development teams. And you don't get accessibility or security or even quality if the company teams aren't really thinking about it and wanting it. And there will always be trade-offs, and regulations will not solve it.
Any other input from the audience?
I guess I wonder, like, a lot of the consequences, though, are not always borne by the companies, but are borne by users or their customers. So isn't that somewhere where regulation could shift the incentives a bit, right? So that the costs would be borne by those imposing.
Yeah, I think that's, for me, that's like where the biggest issue is, right? Is because you have a misalignment between the people who bear the brunt of the cost and the people who are causing the problem, right? And so even if we're not talking about breaches, and in my world, I'm helping people, prioritize vulnerability patches. Okay, I'm helping them prioritize what you should fix, and even in that, you look at the millions of dollars, billions of dollars spent on just applying the latest patches. Just that cost of applying patches to production because my software vendor made a mistake 10 years ago and their security tester just found it. And now we got to patch it, right? That thing's like, that's just a huge cost, maintenance cost that people don't really want to pay, right? And why does the software vendor get away with not paying for some of that? They made the mistake. They shipped the bad code, but there's no control for that. There's no liability shifted back on them. But I guess back to the regulation question, in a lot of the frameworks, people, and Brian, you probably know more about this than I do, but they'll often create some kind of compliance regime saying, here's the 500 things that you need to do to comply with some a standard, and if you do that, you are not liable for problems. But if you don't do it, then people could sue the pants off you because you were negligent, right? My problem with this is that there's no evidence that these particular programs, nobody's testing that these compliance regimes actually make you safer. There are a list of conjecture and hearsay about what people think they should be doing in security that has been carried forward since the 90s that may not apply to us anymore, that don't matter anymore. Who is actually testing with this one control? I'm 3% less likely to be breached. Nobody's doing that, right? So there's a big misalignment between compliance and actually being secure. And that's my problem as a pen tester for years, was like, I'd look at the list of stuff in compliance. I'm like, why am I testing for this? This is not what a hacker's going to do, right? I'm going to do this over here, which isn't even on your list, right? So that's the problem we have right now, is that top down can be very powerful to get people to do stuff, to actually try. But if you're not actually asking them to do the right things, then it's not going to get us any better.
Well, let's talk about this some more. How are we approaching testing of security? And any one of you can take that question. Are we really doing it right? Do we have enough resources? Are we struggling with it? How do we really approach this very important function here? Any one of you can start with.
Well, I can only speak, to my experience, and I don't think there's ever enough that we can do to fully test everything.
Are we doing sufficient? Let's change it.
Well, you're always striving for sufficient for where you're at, but whether or not that's ever truly sufficient, I mean, I think the biggest problem that we have out there is, Tim talked about, the minions and, bringing in all these libraries. Well, as software has gotten more complex and we're utilizing more, third party, but also from what we're building, there's just so many avenues that you can run into vulnerabilities and challenges. So I hesitate to say that we're ever sufficient, but we're always striving for it. And that's what we should strive for. Like within, the company I work for, we're doing external pen tests where we have third parties conduct them. Could we do it internally? Yes. Will it provide some value? Yes, but it's nice to get a third, unbiased party. There's black box and white box versions of those pen tests where, I think both have value. I think everyone should be doing at least that. We should also be doing at least code scanning. There's plenty of open source tools out there. They're free. Yeah, maybe it's not going to catch quite as much as, like maybe using like Black Duck or Veracode, but those are very expensive, right? You're going to spend a lot of money, for those, but how much better is it, right? We do those testing internally. We've got developer trainings on, security, both from development and code reviews. There's all these things to, put in place to try to plug all the holes that you can find in the process. We've also got policies that we need to follow, procedures, the patching that we're doing, externally, looking at all of our open source. By the way, if you don't have an inventory, definitely get one. That's probably the number one thing that people don't even realize. They see, oh, I'm including package A, but you're actually including 150 more. So definitely have an inventory and make sure that you're scanning all of these things, and get on all the mailing lists for all of the published vulnerabilities. That's another avenue for doing it. So I wouldn't say we're ever truly sufficient, because if we were, we wouldn't see an increase in, cyber attacks that are happening. Like right now, between 23 and 24, cyber attacks have been shifting more towards APIs as opposed to the applications themselves. So they've seen it double in a year, where roughly 30% of the targets are now APIs, not the apps themselves. And it's a constantly shifting landscape. So it's something that we're never done. So
Let's see what Brian thinks.
Oh, never done. Yeah, that would be it. I'm struck by a couple of thoughts here. One is, I guess the overall thing is that there are always more risks than you can deal with. This is true if you're looking in any significant code base I've ever been responsible for. There are always more vulnerabilities than we have time to fix. In any security program, looking beyond code, but to the whole security regime at any company, we're always aware of more risks than we have time to address. Furthermore, many of the risks, particularly at the organizational level, don't have airtight controls. There is no way to eliminate the risk completely. If you're looking at a vulnerability in code, you can say, yes, I fixed that vulnerability. You can no longer inject SQL through this input box or whatever. You can block things off there. But between the quantity of things and the indeterminate kind of solution that you apply to raise the bar for the attacker without necessarily being able to block it completely, it's very difficult to say that we ever have a completely secure system. They do it, of course, or try hard to, with great cost in defense, where they have, limit themselves to computer algorithms that can be mathematically proven to be correct, where they air gap the developers' machines, where they do not allow open source software. You have to write all your own. There are extreme measures you can go to reduce greatly the risk profile. But even there, you know, if the stakes are high enough, people will try to get in. So when you ask, do we test enough? I guess the question is partly, the answer is clearly going to be no. But the real question is, what's enough? It's not enough to prevent attacks. That just seems not to be possible in most cases now. It's enough because it's the best we can do given the resources we have. And it is a reasonable effort, good enough for us to put our software out there and have a reasonable hope that we will still survive as a company. We do that kind of enough. Yes.
So we have a few questions online here. Let's address those, and then we will also hang on for a second. Okay.
There are two different questions, but there's kind of similar, at least in the same category. Angela wanted to know about if you guys can talk about the resources of MITRE and the NIST cyber vulnerabilities databases, the CVE MITRE. And then somebody was asking Rethi wanted to know what are some of the code security scanning tools that you might suggest?
Yeah, I'll touch just a little bit on like the code scanning tools, and if anyone else here wants to chime in, but there are a lot of options, right? So don't take just the options that I'm laying out as the gospel. Internally, we're using a product called Arnica. It scans a number of different things, from the static analysis to SCA composition. It's got reputation tracking, IEC scanning. That's a big one to look for, by the way. If you're using any infrastructure as code, it can help you identify potential risks before it ever spins out and catch it in another way. So far, been very happy with it. There are also a number of open source solutions out there that can do basic levels. One that is worthwhile to look at, SonarQube. It's out there. A lot of people are aware of it. A lot of people are using it for a variety of reasons, but it's not just for like static analysis. It's also looking at a lot of just like code structure and other code smells to identify bugs. But it also does provide some vulnerability scanning as well. But what I would definitely recommend is try out a number of different ones. Every single tool that you have is going to generate a lot of false positives. So just because a tool returns back more results doesn't mean it's actually better. You're trying to find that balance, and depending on what language your application's written in, you may find better results in different products. So something to consider.
Yeah, I don't have any specific tool suggestions, but I think I wanted to follow up on what Cory was mentioning about, seeing a huge number of results out of your code scanners or any other security tools that are trying to automatically find risks in technical realms. It's the problem that everybody has, right? Is that there's just too much stuff that this tool is giving me, and how do I decide what to do? I think you really got to change your mindset around from, okay, they gave me a thing, now I have to fix the thing, to what can I learn from the results that are coming out of it? So if I see that, there's 1,000 of these particular kinds of findings that are coming out of your code scanner, and yes, I know a lot of these are false positives. I know a lot of them are not actually valid in my particular situation because I have input validation or I have some other control in my code that prevents it. But turn it around. What can I learn? Why does the code scanner think that's important? Like what was going through the developer's head when they built that particular check? And what are the scenarios where it could be a valid risk in your code? Then use that as a training opportunity for your team to say, hey, this is what they're looking for. These are the cases where it could be bad. You probably don't have this very much, but just be on the lookout for that. And then go in and mark that category of issue as false positive, ignore the results. But you've trained your team on how to avoid it going forward. And maybe the linter or the scanner or whatever will become less noisy later. and just learn, just try to figure out what you can learn from it rather than saying this is just a you know, an automation tool. It's more of a learning experience in some sense.
Brian?
Sure, I don't have a lot to add in the way of specific tools, but I will add that a couple of observations. You should definitely be using SAST and SCA scanners. You should be looking at developer code, and you should be looking at third-party components. Third-party components in particular, there's really no way to manage it in this world without automated help. You pretty much need that to get a list of what you've got. It is not practical to manually track the release times and patches for all the libraries you've got. That pretty much can only be done by tooling. It's conceivable to imagine really good people doing their own source code reviews and catching security, but really not the composition analysis. The other thing I might just mention is that software scanning tools, just like any automated testing tools, have limitations, and we rely on them heavily because we don't have security testing teams, particularly in small and medium companies, teams that just do security testing. The security team at a small or medium company is not focused on testing all the changes that go out. They're advising people, not doing all the work themselves. And you probably didn't hire originally for people who are focused on doing security testing for your QA team, probably. And so because we can't do it all by hand, and because some of it is prohibitively large surface area, we rely on automated scanners. But there are things those are terrible at, like your business logic. And you absolutely do need to include some kind of approach to security-focused, exploratory, manual, non-functional testing in addition to the scanners. Think about what that should be.
Hi, hi, thanks. I was wondering in a few points ago when you were talking about risk and deciding what components to, I guess, identify first or target first. Is there, as security experts, do you have any bias as to whether you're going to pick certain targets, or is that something you try to account for, or do you think there's a more objective way to look at certain components compared to the others?
Could you say what you mean by targets?
Yeah, so if you have like yeah, so if you have like certain components of your system, and you have those components fail, or you have I guess areas of your system that have more risk in quotations than others, how do you incorporate your bias? Do you try to be aware of your bias, or is there something you take into consideration there?
So just elaborate on that. Your UI, your database, your API. So are you having? I guess the question is there any bias as to what do you want to do first or something like that?
The way you're supposed to think about risk, and it is hard to quantify, and so therefore is subject to judgment and errors of judgment, is to list all the risks you can think of, all the things that could go wrong in the database, in whatever layer, in whatever component. And for each risk, consider how likely is that to be exploited? And if it were exploited, how severe might the damage be? Would this just get someone into a slightly elevated access? Would it actually expose the whole database? And then with that set of information, every risk, the severity and the likelihood, that is, you're supposed to be able to prioritize based on that. So things that are high likelihood and high risk, of course, would be at the top. And that would be the general, I think, best practice approach to trying to be systematic about addressing the risk and not just reactive and saying, oh, here's something I heard about and read in the paper today. Have we fixed that yet? The first step should be, oh, let's add that to our risk register. How does that rank in priority to all the other things now, which are at the top of the list, if that helps?
All right, let's go back to your question here. See if you have.
I had a different question, and it kind of gets to something I think Cory mentioned earlier about sort of changes in the last year. And so I guess I'm curious if any of you have any thoughts on emerging or new types of threats, sort of like what might we be not aware of? Like, if I learned a bit about security 10 years ago,
Great question.
Well, I wouldn't necessarily phrase it as like there's a huge emerging, specific new type of threat. What I would say that I'm seeing a lot more of is there's an emergence of those threat actors, like more and more potential threat actors, and the automated tools that they have at their disposal today to be able to initiate attacks, we've seen on the rise and increase. But we see a lot of the same attacks happening all over. Some, have ballooned in, the how common they are. Probably the one that we hear about a ton is ransomware attacks. They're happening all over, and they happen to everyone because it's really just getting something into the system, and then if it can run, it just starts taking over. And you'll hear about these all the time, and they're always occurring because we're talking a lot about, securing our applications and doing everything that, we can to be able to test and verify that that's good. But the easiest vector is people. Always has been, always will be, because the people, working in these environments are going to have varying degrees of access and credentials and their knowledge level when it comes to security. Phishing attacks, super common. I mean, they're happening multiple times a day to probably everybody in this room. We probably see them. Well, it's happening to everybody you work with and everybody at your customers' locations and everywhere else. So that just makes ransomware, probably the easiest to implement because it just takes one user that has access to click on something. And you could have done everything else right, and it still, comes to the door. So it's really, I don't know if there's like an emerging threat. I mean, there's interesting thoughts around AI and how that may, play into it, but I haven't seen anything with like, that's credible on what it's actually going to do. It's more conjecture at this point, but it's a lot of the same things that we've seen. And Tim?
Yeah, I mean, I think I second that. And, what I've, when I was doing consulting, I did a number of phishing engagements where we'd actually intentionally phish our customers to help test their employees and help and educate them and that kind of thing, right? And those were kind of fun engagements, but and we had very high success rates when you craft an email the right way to the right people, and you take the time to think about it. We managed to phish CISOs who paid for the assessment, and we phished them. Okay, they knew the day the email was going to come out, and yet they were still fooled. Okay, now throw a little Gen AI into that. So instead of us spending a whole lot of time crafting an email exactly the right way, you could maybe automate that at a reasonably good level. And suddenly the phishing attacks are way more effective. One of the tricks that a lot of attackers use these days with phishing is they'll shotgun out a bunch of phishing attempts against your employee base, and maybe only one or two people get actually hit. And then they'll immediately take control of that email account and they'll phish internally. So they go from the real email account to the rest of the employees. That doesn't get blocked by your spam filters, right? And suddenly the second hop in the phishing chain is actually gets somebody with access, to something important, right? So I think that's one area that I'm really worried about. It's the same threat. It just suddenly is much more automated and much more effective.
Well, I think food is out there and people probably want to go eat. So I would first like to thank you for participating here. We really appreciate your thoughts and advice and your knowledge you just shared with us. And thank you everyone for attending.